At the top of Alaska, beneath a landscape that can look almost empty, sits one of America's strangest energy contradictions. The pipeline built to carry Alaska's oil once moved more than 2 million barrels every day. In 2025, it carried less than 1/4 of that amount. And yet, the North Slope may still contain billions of barrels of undiscovered oil that could potentially be recovered using existing technology. So Alaska's biggest oil problem may not be that it is running out. It may be that the next generation of oil is arriving just as the enormous system built to transport it enters its most difficult era. One major field has just begun producing. Another is under construction. Together, they could reverse decades of decline, but only if geology, engineering, economics, and politics all line up at exactly the right time. This is Alaska's biggest untapped oil frontier, and the race to develop it could change everything. The frontier is not one isolated oil field. It is the vast North Slope, the Arctic region between the Brooks Range and the Beaufort Sea, stretching from the National Petroleum Reserve in the west toward the Arctic National Wildlife Refuge in the east. For decades, this region has been dominated by one name, Prudhoe Bay. Discovered in 1968, Prudhoe became the largest conventional oil field in North America. But its location created an obvious problem. The oil was more than 800 miles from an ice-free shipping port. The solution was the Trans-Alaska Pipeline System. Completed in 1977, the pipeline carried crude south from Prudhoe Bay, across mountain ranges, rivers, earthquake zones, and permafrost, before reaching tankers at Valdez. It turned an isolated Arctic discovery into one of the most important oil-producing regions in the United States. At its peak, North Slope production helped move more than 2 million barrels through the pipeline every day. But Prudhoe Bay could never remain at peak production forever, and as its output declined, the entire system built around it began to change. In 1988, the Trans-Alaska Pipeline averaged just over 2 million barrels per day. By 2025, average throughput had fallen to approximately 463,000 barrels per day, the lowest annual level in its history. That decline is not merely an economic statistic. It changes how the pipeline physically behaves. With less oil inside it, the crude moves more slowly. Slower oil loses more heat during its journey, and colder oil creates a growing list of operational complications. Small amounts of water carried with the crude can freeze. Wax can accumulate along the inner wall. Maintenance becomes more complex, and the oil remains inside the pipeline for much longer. A journey that took approximately 4.5 days in 1988 can now take around 19. The pipeline continues to operate reliably. In the first half of 2026, it was still carrying roughly 459,000 barrels per day. But declining flow creates a clock hanging over every new North Slope discovery. Finding oil is only the first step. Alaska must discover enough of it, develop it economically, and connect it to existing infrastructure before falling production makes the system even more challenging to operate. And this is where the story takes an unexpected turn, because after years of decline, explorers began finding major oil accumulations inside rocks that had once been overlooked. Much of the new excitement centers on the Nanushuk and Torok formations. These layers formed tens of millions of years ago as ancient rivers transported enormous volumes of sand and sediment north into a marine basin. For years, oil companies concentrated on deeper and more familiar geological targets. But improved seismic imaging and new drilling results revealed that younger, shallower formations could also hold major quantities of oil. In one assessment, the United States Geological Survey estimated a mean of 8.7 billion barrels of undiscovered, technically recoverable conventional oil in the Nanushuk and Torok formations. The assessment covered the National Petroleum Reserve, adjacent state and Alaska native lands, and nearby state waters. That number sounds extraordinary, but it comes with an important warning label. Undiscovered means much of the oil has not been confirmed by drilling. Technically recoverable means existing technology might be able to extract it. It does not mean every barrel will be profitable, permitted, or eventually produced. Still, the estimate revealed that Alaska's next oil chapter might not depend on finding another Prudhoe Bay. It could emerge from a chain of discoveries spread across one enormous geological play, and one of the clearest demonstrations of that possibility has just entered production. The Pikka project sits west of Prudhoe Bay on state and Alaska Native Corporation lands. Its oil is trapped within the Nanushuk Formation. Rather than building an entirely independent petroleum system, the first phase was designed around a concentrated limited footprint, one drilling site, a processing facility, and connections to infrastructure already operating on the North Slope. By June 2026, Pikka had begun continuous production, with its first wells delivering approximately 20,000 barrels per day. Its operators plan to bring additional wells online and target around 80,000 barrels per day during the third quarter of 2026. That would be significant on its own. It would equal roughly 1/6 of the oil recently moving through the Trans-Alaska Pipeline. But Pikka matters for another reason. Its first phase brings approximately 400 million barrels of gross, proved and probable reserves into production. Its developers also report additional resources that could support later expansions. In other words, Pikka is not a distant geological theory. It is physical proof that the North Slope can still support a large, modern oil development. And its timing could not be more important. After decades in which aging fields lost production faster than new projects could replace it, federal forecasters expected Pikka, together with the smaller Nuna development, to produce Alaska's strongest annual oil production increase in decades. But even an additional 80,000 barrels per day would not return the pipeline to anything close to its peak. For that, Alaska would need something much larger. And approximately 120 miles farther west, inside the National Petroleum Reserve, that project is already being built. Willow is the largest new oil project currently under construction on Alaska's North Slope. ConocoPhillips estimates that it could produce approximately 600 million barrels over its lifetime and reach about 180,000 barrels per day at peak production. That is more than twice Pikka's planned plateau. And because Willow would feed into the wider North Slope network, its oil could become a major new source of throughput for the Trans-Alaska Pipeline. But there is a catch. Willow is not expected to produce its first oil until early 2029. By early 2026, the project was approaching 50% completion. Crews had built bridges, installed dozens of miles of pipeline, and expanded year-round operations. But Arctic construction follows a calendar unlike almost anywhere else. Heavy equipment often travels during winter, when frozen ground can support temporary ice roads and reduce damage to the tundra. Materials must be shipped enormous distances. Construction windows are short, and delays are expensive. ConocoPhillips has placed Willow's total project cost at approximately $8.5 to $9 billion. That means Willow is not simply an oil field. It is a multi-year bet on what oil demand, prices, regulation, and infrastructure will look like decades into the future. And before its first barrel reaches the pipeline, the project must navigate another challenge, one that cannot be measured only in dollars. From the air, the North Slope can appear vast and unoccupied. It is neither. The National Petroleum Reserve covers roughly 23 million acres and contains rivers, wetlands, and special areas important to fish, migratory birds, and caribou. It is also part of a living cultural landscape for Inupiat communities, whose traditions and food security remain connected to subsistence hunting and fishing. That is why Willow has produced such sharply different reactions. Supporters point to construction employment, local revenue, public services, and the long history of North Slope communities participating in Alaska's petroleum economy. Critics focus on greenhouse gas emissions, industrial expansion, habitat fragmentation, and the possibility that roads, pipelines, aircraft, and traffic could affect caribou movement and access for subsistence users. The federal government reduced the approved Willow design from 5 proposed drill pads to 3. The decision eliminated miles of roads and pipelines, required ConocoPhillips to relinquish rights to approximately 68,000 acres of existing leases, and added measures intended to reduce impacts around caribou habitat and subsistence use. A later conservation agreement also provided protections across roughly 1 million acres of important Teshekpuk caribou herd habitat. But mitigation does not erase the conflict. For communities closest to development, oil can finance employment and public services, while also placing additional pressure on the land and animals that have supported Arctic life for generations. That tension is not a side story. It is one of the central forces determining how much of the North Slope's geological potential will ever become actual production, because underground resources do not become commercially recoverable reserves through geology alone. They become reserves when they can be developed legally, economically, and acceptably. So what happens if Pikka reaches its planned plateau and Willow eventually reaches peak production. Together, the two projects could contribute roughly 260,000 barrels per day before accounting for the decline of older fields, maintenance, production ramp-ups, or any later expansions. That would not return Alaska to the 2 million barrel per day era. It would not make the United States independent of the global oil market, and it would not mean every estimated barrel beneath the North Slope could suddenly be produced. But it could change the direction of Alaska's oil industry. New production can distribute the fixed cost of infrastructure across more barrels. It can extend the useful life of processing facilities, roads, pump stations, and the Trans-Alaska Pipeline. It can support state and local revenues, and it can encourage companies to investigate smaller discoveries that might be uneconomic without nearby infrastructure. This creates a powerful feedback loop. Infrastructure makes new fields possible. New fields help preserve the infrastructure, and preserved infrastructure makes the next discovery more valuable. But that loop also works in reverse. When new projects are delayed, existing fields continue to decline. The pipeline carries less oil, operating challenges increase, and discoveries that appear attractive on a geological map can become harder to justify financially. The real race is therefore not between Alaska and another oil-producing region. It is between the next generation of fields and the decline of the system they need. This is what makes the North Slope America's most unusual untapped oil frontier. It is not unexplored wilderness in the old sense. Oil has flowed here for nearly half a century, and it is not one hidden superfield waiting for a drill bit. It is a mature petroleum region entering a second geological act. Pikka is proving that newer formations can support major production. Willow could add a much larger wave near the end of the decade. Nuna and other satellite developments can fill smaller gaps around existing fields, and beyond them remain billions of barrels that geological assessments classify as potentially recoverable, but that have not yet been discovered, financed, or approved. The question is no longer simply whether oil exists beneath northern Alaska. The evidence says that it does. The harder question is how much of it can cross the enormous distance between potential and production. Alaska's biggest untapped oil frontier could change everything, but probably not in the way the title first suggests. It will not recreate the original Prudhoe Bay boom overnight. What it could do is more subtle and, for Alaska, perhaps more important. It could turn a decades-long decline into a new period of growth. It could help keep the Trans-Alaska Pipeline relevant for another generation, and it could determine whether future discoveries become producing oil fields or remain numbers inside geological reports. The North Slope is not running out of possibilities. It is running against time, and the next few years may decide how much of Alaska's oil future ever reaches the surface.